Today's lesson is all about biomedical engineering, and that's how engineers take all the science and maths that they learn and apply it to problems in the human body and even in animals. The objectives for today's lesson are to teach kids about biomedical engineering, so they might not be familiar. The detailed objectives are to try and teach kids about different biomedical devices such as knee replacements, pacemakers, heart valves. We want to have some pictures and we want to get familiar with different devices. They may even have relatives who have something implanted. The video then, we're going to take a few minutes to talk through that. It's really, really interesting and can creep a few kids out as well. And then finally the activity is probably going to make up the bulk of the lesson. One thing to note with biomedical engineering is it's a hugely popular field in Ireland. So about 75% of the world's heart stents are made in Galway, for example. We have DePuy Synthes, Boston Scientific and Stryker all working down in Cork and across Ireland. So if you ask any of the kids in the class if they have relatives working in these companies, it usually generates a bit of excitement. So our second video of the day is about a prosthetic thumb. And one thing that's really interesting about this is it leads very well into our activity, because if you look at how the prosthetic thumb works, there is a string that connects down here, and as the string is wound in, it pulls in the thumb, and vice versa when the string is wound out. And what we can do then is we go around to the kids and we try and teach them that our muscles and bones work in a very similar way. So what I try and do is if I pinch my fingers here, you can see tendons that run up your arms, and a nice little thing to do with the kids is ask them how we move. Most will have an understanding of muscles and bones, and if you ask them then how many muscles we have in our hands, you'll wait for a few answers, and it's 0. And you can tell them then that all of the movements in our fingers are controlled by what are essentially strings that connect to muscles in our forearm. And we should have a nice collection of kids messing in the classroom doing this. They're very obvious on the back of our hands, and so moving fingers like this, we can teach kids all about how our prosthetic thumb in our video works on the very same principle as our hands, and that leads nicely into our activity. So I'm going to use the materials now to build our arm. There are a couple really important tips and tricks in this that if you don't do correctly, it's quite difficult to get a nice result. So when the kids finish, the ideal kind of proof of concept is that they can use their hands to go pick something up. We don't want any kids being too disappointed in how it turns out, so take these lessons on board and be really sure to say them before the kids start chopping. So here are our materials. We have the foam tubes, we have our cardboard tube, and we have our string. So these are the important ones. We also have a wheel at the end. The wheel is it's important, but it's not essential. So what we do is we want to make sure that our foam fingers are at least, I would say, 2 inches or more over the edge, and then the length of the finger on top. So if we cut these all too short at the start, it doesn't work very well. So I'm going to take one. So we have our 4 fingers now. We have our cardboard tube. What's important next is the inside of the finger. So these are what gives the finger its rigidity and what makes it return to the position it was in. We'll have 4 of these. And what's important here, and what often gets mistaken, is our foam goes outside and extends beyond, whereas the finger should sit exactly on the top of the cardboard. By sitting on the top of the cardboard, it means it won't pull down, and because it's all tied together, it means the finger and the foam will move as one. Do 1 or 2 of those now. So we have each of these needs to have a hole placed in the top. That hole will allow the string to connect and should be pulled down through the center. So carefully, using edge of the scissors, punch a hole close as you can to the top of each of these. In one of the grooves is generally handiest. Next then, cutting lengths of string. So the length of string has to be long enough to go from the top of the finger down through the cardboard tube and have something to grip on at the bottom. String is not in short supply, so don't be afraid to use enough. We have our hole here, so the string must go through the hole One easy way to do that is to take your scissors and to force it through. When it's through the far side, tie a knot. One down. So unlike a normal hand, it's probably best to have these on the 4 sides of the clock. So that would be 1, 2, 3, 4. Some kids have a tendency to put them all together like our own fingers, which obviously won't work as well. Try and think of it more like the claw at the amusements than a hand. What our disc is for is to provide a way for all of these to be pulled together. If you just tie a knot in that, then it means you can pull on the disc and all 4 fingers will move together. But to the joy of editing, we have one we made earlier. So this is the same way. You have 4 fingers. The only difference here is the white plastic. And each of the strings comes down through the middle. They collect to the bottom. You can pull them and your hand will open and close. So if I'm being really tempting fate here, I'd say boom. There are a collection of stickers that come inside the pack. Kids are free to decorate. The most important thing would be to leave sufficient time for this lesson. It can take as much as 25 minutes because some bits are quite finicky. Expect a few kids to make some mistakes and go back and help them. But if from the outset you warn them about the plastic sitting on top of the cardboard, the foam being longer than the finger itself, and the string having to come out the bottom, those are the 3 common mistakes, and they should be well able for it. So to finish the lesson, you just want to make sure you've covered the basics in terms of how our arms move compared to the prosthetic arm you're building. You want to talk about biomedical devices, how they're really common in Ireland, all the different kinds of procedures like hip replacements, knee replacements. We watched a video, an animation of a knee replacement being done. If kids are brave enough, you can invite them to watch the real thing on YouTube. Also things like shoulders and hips, really interesting videos, all under the same concept. So you can refer to the slides for this week's question pertaining to next week's lesson.